Hi, Assalamualaikum. Today my group would like to present about our task mini project of fluid mechanics, which is about hydraulic elevator. This is our group members for this task. So my name is Karunisha Nadia binti Muhammad Sobran, with the number ID is 551041200002. Would like to present about the introduction of hydraulic elevator. Hydraulic lift and hydraulic elevator such as the same thing. The both of them, the function is to move objects by applying pressure to liquid in a piston to create force. Hydraulic lift technology can be found in hydraulic jets, forklifts, car lifts, among many other machines. Elevators that are powered by a piston that travels inside a cylinder are known as hydraulic elevators. To move the piston, an electric motor pours hydraulic oil into the cylinder. The elevator cap is lifted smoothly by the piston. The discharge of the oil is controlled by electrical valves for the smooth smoke. There are three types of hydraulic elevators, which is whole hydraulic, holeless hydraulic, rope hydraulic. That's for the history of hydraulic elevator. The earliest elevators were called hoists. They were powered by human and animal power, or sometimes water driver mechanisms. Modern elevators were developed during the 1800. These elevators slowly evolved from steam driven to hydraulic power. In 1852, Elisha Gravers introduced the first safety contrivance of our elevators. Werner von Siemens, a German inventor, created the first electric elevator in 1880. First commercial Weber electrical elevator was installed in 1889. 1887, a patent was issued for an electrical elevator with automatic doors that would block off the elevator shaft. Then the elevator completely done. Thank you.
My name is Nurul Aisyahirah binti Abdul Basit, and my ID number is 551041200010, and I'm going to present about theory of Pascal's law. Theory of Pascal's law. Pascal's law states that the pressure that occurs anywhere in a confined compressed fluid is distributed throughout the fluid until the same chain. According to Pascal's law, in a hydraulic system, the pressure on a piston produces the same increase in pressure. The pressure at each point in the fluid is the same in all directions. We know that Pascal's law formula is F equal PA, where F is force applied, P is pressure transmit, and A is area. Point B. The above law means that if we consider a fluid confined in a particular region or space, and if the volume of the fluid does not change with pressure, the amount of pressure given will be equal to the amount of pressure transmitted. Point C. Consider a round vessel that has 4 openings, and along these 4 openings 4 pistons are attached. When piston A is moved downwards, pressure is applied to the fluid downwards. This pressure is distributed evenly along all directions. As a result, all the other 3 pistons move the same distance upwards. Point D. A round vessel equipped with a piston that move at all 4 of its ends, and when piston A is moved downwards, pressure is applied downwards. The same amount of pressure is applied along a direction so that they will move the same distance upward.
My name is Lailatul Zafira binti Zamahuri alias Zamanuri. My ID is 5510412448. I would like to present about application of hydraulic elevator. A hydraulic elevator can be found in almost any type of building but rarely found in high-rise buildings. They are widely used in buildings up to 5 or 6 stories tall, sometimes but rarely up to 8 stories high because it's a lot of energy to raise the cap. They operate at speeds of 150 feet per minute or less, which is lower than other types of elevators because they do not rely on large overhead hosting machinery like geared and gearless traction system too. There are 4 types of hydraulic elevator. First is whole hydraulic. With this type of elevator, hydraulic cylinders extend into the ground and are placed inside of a drill hole. The car of the elevator is mounted on a piston that travels inside of the cylinder, allowing up to 60 feet of travel. Second is holeless hydraulic. Since a drill hole is not necessary, existing buildings or areas where drilling is not an option can benefit from a holeless hydraulic elevator. However, these models are not suited for more than 40 feet of travel. Next is rope hydraulic. Rope hydraulic elevators use cables and a piston attached to a shaft as standardized of a holeless hydraulic elevator. Since a rope is holding up the elevator cap, a governor is required. These models are intended for 60 feet of travel. Last but not least, machine roomless hydraulic. In machine roomless elevators, the hydraulic lift mechanisms are located in the hoseway instead of a separate machine room. This maximizes the available space in a building. Prior to the arrival of machine roomless elevator, height restrictions and sun shadows regulations, among other factors, mean that the actual building had to be considered, and hydraulic elevators were used when there were limitations such as not being able to load heavy equipment. Because of their high capacity and sustainability for transporting heavy loads, these elevators are currently in use in factories and warehouses. However, due to their structure, they are almost always used in low-rise buildings.
My name is Izzatul Anjida binti Abdul Samahuri. My ID is 551021200062. Hydraulic elevator component. In the hydraulic elevator component, there is two main part. The first one is the system, and the second one is the machine. For the machine, there is a four component inside it. The first one is a manual reset stack group safety switch, and the second one is anti-creep device. The third one is a buffer, and the fourth one is brake governor. This device is to help in ensure the safety of the people inside of the building. The next main component is a machine. In a machine, there is a piston, plunger, and a jack. There is also a hydraulic power unit. In the hydraulic power unit, there is a four component. The first component is hydraulic pump that convert mechanical power into hydraulic energy. The second one is hydraulic motor, is an actuator to convert hydraulic pressure into torque and rotation. The third one is hydraulic fluid transfer of power in a hydraulic system to generate movement. The last one is hydraulic cylinder that convert the energy in the hydraulic fluid into force and irritate the pressure in the fluid that is controlled by the hydraulic motor. For the hydraulic elevator, there is 3 advantages and 3 advantages. The first one for advantages is this elevator is less expensive to install and maintain than for transporting heavy load. It will also occupy less spaces in a building, and there is an option to have a machine room-less configuration. For these advantages, hydraulic elevator can only travel up to 150 feet per minute, and it can be a bit noisier than other systems. This hydraulic elevator also intended for low and mid-rise building, as it cannot travel to a high building due to the system.
My name is Nur Khairina binti Ghazali and my ID is 5510200083. So, for the conclusion is, high energy consumption and environmental issues raised by MRL traction manufacturers against hydraulic elevators are not entirely reflecting the reality. Next, applications of hydraulic systems are inevitable in many industrial practices. Hydraulic elevators have unbeatable properties such as breakdown, free operation, low initial cost, easy installation, and high comfort. Hydraulic elevators also have the best records in safety and servicing costs. It is also must be remembered that the cost of servicing an elevator is much higher than the cost of operating an elevator. Services and spare parts for hydraulic elevators are freely available in the market without having enforcing contracts. Next video is example of overview, basic structures and features of hydraulic elevators.
Hydraulic elevators use an electrical pump to operate a hydraulic cylinder which lifts and lowers the elevator. They have large carrying capacities, making them appropriate for transporting heavy objects. There are direct acting lifts in which the plunger, which expands or contracts under hydraulic pressure, is directly connected to the bottom of the cab, raising and lowering it. And indirect acting lifts, in which the expansion and contraction of the plunger pulls on a rope, causing the cab to rise or lower. The majority of the hydraulic elevators delivered in Japan are indirect acting lifts. The equipment consists of a hydraulic power unit, hydraulic cylinder, and cab. The location where the hydraulic power unit is installed can be laid out somewhat freely, and there is no need for a rooftop machine room. Because of this, until the development of machine roomless elevators, these types of elevators were frequently used in buildings with height limitations, buildings with sunlight blocking restrictions, and buildings with weight restrictions. They have large carrying capacities and are appropriate for transporting heavy objects, so they are now used in factories, warehouses, and the like. However, for structural reasons, they are mostly used in buildings with few floors.